Hi, everybody. We are going to be talking about Chapter 1 today, and it is all about the introduction to human development. So, one of the things that our chapters go through is fact or fiction. The science of human development is the study of how and why people change as they grow older, as well as how and why they remain the same, and this is true. Next one, an experiment is always the best way to investigate a developmental issue. This is not actually true. Developmental psychologists almost never base their research on the study of one group of people over a long period of time. This is false. When two variables are correlated, it means that one caused the other, and this one is definitely false as well. What causes people to change or remain the same over time? Like every other science, developmental studies depend on theories, data analysis, critical thinking, and sound methodology. And the science of human development is seeking to understand how and why people of all ages and circumstances change or remain the same over time. So the question of nature versus nurture, like which one has more and which one factors more into our development. Eating the same diet will affect individuals in different ways since each person has his or her own genetic vulnerability. That vulnerability, coupled with behaviors related to eating, affect an individual's weight and health. Genetic vulnerabilities does not only apply to nutrition and eating. In a famous developmental study from New Zealand, a variant of the MAOA gene in boys, along with the kind of parental treatment they received, affected the likelihood of some subjects to commit a violent crime. So nature has to do with traits, capacity, limitations each individual inherits genetically from parents. That happens at conception. Nurture is all about the environment. There may be more than one factor, including genetic vulnerability, involved in teratogenic effects, and more than one kind of teratogenic damage. We know that tobacco increases the risk of malformation of limbs, the urinary tract, and may affect a baby's lungs. Untreated, a baby born with syphilis may experience brain and bone damage and eventual death, but it's often difficult to tell which factor has caused a teratogenic effect. Tragically, between 1957 and 1961, thousands of newly pregnant women in 30 nations took thalidomide, an anti-nausea drug. Thalidomide disrupts a critical period of development between days 28 and 54, so women who took that medication during that time had newborns with malformed or absent limbs. So what happens when a potentially harmful agent, a teratogen, is introduced at a critical period of prenatal development? Well, for radiation, we know that there's growth and developmental retardation if it occurs between 3 and 8 weeks after conception. So oftentimes people don't even know they're pregnant at that time. Tobacco, we know that children have lower birth weight and they can actually have some other issues, and that can affect them throughout the entire pregnancy. Alcohol, we know that the 3 to 8 weeks is absolutely the most critical in terms of fetal alcohol syndrome. Same thing, so many people don't even realize they're pregnant at that time. We can have fetal alcohol effect, growth and developmental retardation, and craniofacial dysmorphism. Cocaine, we know that after 17 weeks that they're premature, can cause premature birth, problems with the placenta, low birth weight. And these all have things that are called critical periods when a particular type of development, growth, in body or behavior must happen if it is ever going to happen. And then there's something called a sensitive period when a certain type of development is most likely, although it may still happen later. Up until about 50 years ago, developmental researchers mostly studied children up to about age 18. It's now apparent that adults of all ages, as well as children, are continually affected by one another and by life circumstances. So this has to do with the dynamic systems theory, that it's ongoing. We don't just stop developing at 18. We look at how people interact with each other. We do so continuously over time. At any age and life stage, gains can lead to losses and losses can lead to gains. Every change produces unexpected advances or retreats. And that has to do with, that's where we're talking about with multidirectional, that how human characteristics change, they can change in every direction at all different times. In the 1970s, Yuri Brofenbrenner identified different levels and systems that interact over the life of an individual. He named this theory the ecological systems approach and then renamed it the bioecological theory toward the end of his life. And this is specific that it's basically saying that a person has to be considered within the context of life in general. So the first circle is like that, the person. And then there's microsystems around him, the family, the classroom, the peer group, and religious class. Then there's the exosystem, which has to do with the school system, medical institutions, mass media, and community. And by mass media, think about TV exposure, internet, ads. The next bubble around is macrosystems, and that has to do with the social conditions. Like, for instance, right now in our economic world, there's a lot of economic hardship versus 20 years ago, people were, doing much better financially. So that does affect the child. The father loses his job and comes home and is very upset and angry around the child, or they lose their home because of it. So what's going on with the parents and their work environment and the economic environment definitely affects the child. And then there's the chronosystem, which is basically all of the systems, interacting with each other. Unlike genetic differences, social constructions, which are the ideas created for a society, can change. But being a member of an ethnic minority group does not mean you have a common cultural experience with all the other members of that group. So one of the things that we're talking about with culture is just because you come from the same cultural background as someone doesn't mean you've had the same experiences. So culture is the enduring behaviors, ideas, attitudes, and traditions shared by a large group of people. And your ethnic group is people whose ancestors were born in the same region and who often share language, culture, and religion. And then there's race, a group of people who are regarded by themselves or by others as distinct from other groups on the basis of physical appearance. Researchers in various disciplines see important implications in the discovery of mirror neurons. For instance, social psychologists think mirror neurons help people empathize with one another. Cognitive psychologists suggest that mirror neurons explain newborns' ability to imitate what they see. So that whole what monkeys see, why does monkey do? So mirror neurons are cells in an observer's brain that respond to an action performed by someone else in the same way they would if the observer had actually performed that action. Here's an example of what the flowchart shows. When one woman's brain area for balance was destroyed due to a prescription drug overdose, neuroscientists successfully reprogrammed her brain, which allowed her to move with balance again. But plasticity doesn't mean that anything is possible, just that change may occur, for better or worse. Keep in mind that every trait within an individual can be altered at any point in the life span. Also remember that change is ongoing, although neither random nor easy. So brain damage has an injury, and if the brain is plastic enough, it can actually create neurons to have other pathways. And that's why people that have brain injuries, you see different levels of success for recovery. And plasticity is human traits can be molded as plastic can be, yet people maintain a certain durability of identity. The scientific community accepts conclusions with replication, which is the repetition of a study using different participants. So you can think of replication as a sixth step in the scientific method. Although reliance on evidence is intended to eliminate bias, scientists realize that any single study may include unknown distortions. Therefore, replication, elaboration, and analysis by other scientists are needed. So one of the first steps is curiosity when you raise a question. Then you develop a hypothesis. And this is probably sounding a lot like your science fair projects you had to do when you were younger. A prediction that can be tested. Then you're going to test the hypothesis. You want to design and conduct research, gather empirical evidence. And then you're going to draw conclusions. And conclusions are either going to help you support or refute your hypothesis. And then you report the results. This is called the scientific method. And when you report the results, you're sharing data, conclusions, and basically any alternate explanations, because it may have been refuted, but that also gives you some results. Observations may take place in a natural setting, in a laboratory, or in searches of archival data. The purpose of being unobtrusive is to avoid influencing the behavior of the people you're watching. In this class, you're actually going out and doing 3 observations, and the whole point is to observe the child, but not intervene or have them interact with you. You want to be an unobtrusive observer. So a method of testing a hypothesis is by unobtrusively watching and recording participants' behavior. Elections would be easy to predict if people voted as they told takers they would. If we want our survey to accurately describe a population, the sample we survey should be selected randomly from the whole population, not just selected conveniently based on the people we come across. So surveys are interesting because sometimes they're self-selected by people who are willing to stay and answer questions, or if we send them like a surveymonkey.com, people that are willing to actually fill it out. So information is collected from a large number of people, and we want them to be completely randomly selected. So if we wanted to know how people are voting, we should be driving all over town to different polling places and asking people. But a lot of times they'll respond the way they think you want them to respond, so they may not respond accurately. And basically acquiring valid survey data is not easy. Some lie and some change their minds. Participants are divided into 2 groups, matched on important characteristics, especially the behavior that is the study focus. To make sure the groups do not differ in any way besides the variables being tested, participants are randomly assigned to either the experimental group or the control group. And this is how you would set up an experiment to test the hypothesis. There'd be an independent variable, and then there'd be a dependent variable. The dependent variable, which is the variable that depends on the independent variable, and special treatment or intervention is given, that's the independent variable to one group, the experimental group. And this is basically how you're going to design an experiment. You'd have the experimental group and a comparison or control group. One's going to get special treatment, which is the independent variable. One gets no special treatment. And basically you're going to look and see if there's any change. Sometimes when you give no special treatment, let's say it's looking at medication, you'll give a placebo because you want to see if there's emotional, like people think they're getting better because they're on the pill. So you give them something they think is a pill and you see if they're getting better even if they're not on the medication. Cross-sectional studies confound age and cohort effects, so these results look more pessimistic than necessary. Longitudinal studies confound age and historical time, so you can't tease out a number of differences related to a subject's age between testing times. The cross-sectional study makes older folks look less intelligent, but those people were educated in a different era. And that's basically now. We look at how, I look at just having my children 7 years apart. My son, when he was 3, my youngest, was so amazing on the computer and with the mouse, while my older son, who's now 14, didn't have 9 years ago. We didn't have the computers that we have now and wasn't as proficient on the mouse and didn't know how to use an iPad. So it is amazing to see the difference in just a few years and exposure. Cross-sequential study will analyze data 3 ways. First, it will compare groups of the same ages studied at different times. Any differences over time between groups who are the same age are probably cohort effects. The second analysis compares people within a group. As they get older, any differences are the result of time, not only age. And the third analysis compares differences between the same people as they grow older, but after the cohort effects are taken into account from the first analysis. Any remaining differences are almost certainly the result of age. You can find the cohort effects by following the diagonals. This is the most time-consuming and complex research designs, but it yields the best information. And actually, our discussion for this week is all about you discussing your cohort. Correlation and causation. A correlation indicates that only 2 variables are related, but not that one variable causes the other to occur. For instance, when there's a correlation between immigrants in the United States when compared with native born in the same ethnic group and having fewer low birth weight babies, but the status of immigrant alone doesn't cause a woman to not have a low birth weight baby. Always remember that correlation is not causation. So let's look at ice cream sales and murder rates. We found that there's a positive correlation. Do you really think that ice cream sales and murder rates are associated, that as murders increase, ice cream sales increase, that they cause the other? And the third variable is actually heat. So why would that? It is that we have found that people, when there's extreme heat, get very agitated and angry and aggressive. And so a lot of people are having ice cream because of the extreme heat, but then there's also a higher murder rate because of it. So there's not a causation there. So learning to read in the number of baby teeth, that's actually been, a lot of people say there's a correlation between the two. It is a negative correlation, and it actually has to do with just, the age. Most children learn to read when they're losing their baby teeth, because that's the age when all that's happening. It's not the cause. It's not a coincidence either. It's around the same timing. And sex of adult and their average number of offspring, zero correlation. No third variable. Each child must have a parent of each sex, and that has to do with just how conception occurs. So how is quantitative and qualitative research used? Most institutions of higher education emphasize quantitative data. Sometimes scientists translate qualitative research into quantifiable data. Sometimes they use qualitative studies to suggest hypotheses for quantifiable research. So quantitative has to do with numbers, and that's why many institutions like it, because it gives you specific statistics like 5% increase, 3% decrease, and makes it a little easier. Qualitative has to do more with qualities instead of quantities. Most institutions of higher education emphasize quantitative data. Sometimes scientists translate qualitative research into quantifiable data, and sometimes they use qualitative studies to suggest hypotheses for quantifiable research. And one of the things to be aware of is when you're doing research, when all of these institutions are doing research, they have to make sure they're treating everybody ethically. When I did my dissertation, I was looking at children with cancer and their support from friends helping them return to school. And one of the things I had to do was go through the ethics committee at the college and have them okay every measure I was looking at and stamp it and say that it was ethical to ask the children these questions, ask the family questions, ask the schools questions. And so they're very strict about that. We would never intentionally harm someone through research. So this is the end of chapter 1. Now I want you to go into the forum section and respond to the discussion about your cohorts. And I also want you to remember to look at the rubric so you're aware of what's expected in terms of how to get the grades that you want to get on your discussion. And additionally, I want you to remember to fill out the crossword puzzle, and you need to be using the search browser Firefox in order to see the clues. Thank you.